Hi, in this video I will talk about multi-head attention. Before multi-head attention, let's inspect its building block self-attention. Self-attention interprets the relation between input vectors to get an idea about the context. Specific version used in transformer is called scaled dot product attention, and it is described in Attention is All You Need paper. Multiple self-attention blocks are used in parallel and called multi-head attention. Input and output of self-attention have the same number of vectors. For each input vector alpha I, a query, a key, and a value vector are computed. Query, key, and value vectors are linear projections of alpha I. A linear projection is implemented using a dense layer with no bias and no activation function. WQ, WK, and WV are weight matrices of dense layers. Query, key, and value terms are used in information retrieval systems. Let's say you look for a file inside a set of files. Query is how you describe the file you are looking for. Each file in the set is attached with a description which is key. Content of each file is its value. So, query is compared with the keys of all files. Result is a relevance or similarity score for each file in the set. Inside self-attention, value can be thought of as information content extracted from input. Query of each input vector is compared with the keys of all input vectors to find out which is similar at which degree. Dot product is used as the similarity metric. To compute each dot product, query and key vectors should have the same dimension dk. Value vectors may have different dimension dv. In softmax input, if one logit is very high compared to others, then softmax output resembles a 1-hot vector. If high output corresponds to ground truth class, loss and gradient become very close to zero. So magnitudes of dot products should be kept low. If components of query and key vectors are independent random variables with mean 0 and variance 1, then dot product of a query and a key vector has mean 0 and variance dk. Dot product is scaled by 1 over square root dk to keep the variance at 1. Each row holds the scaled dot products of the query vector of one input with the keys of all inputs. Optionally, if some entries of this matrix shouldn't be included in the process, they are masked by setting them to negative infinity. Because inside softmax, e to the power negative infinity is 0. This is the case in transformer decoder for NLP applications. Applying softmax to each row separately, attention weights for each input are obtained. Sum of each row is 1. So attention weights are not fixed or learned, they are computed for each input. As the last step, each output is computed as a linear combination of value vectors weighted by attention weights. Output vectors have the same dimension with value vectors. As similarity indicated by scaled dot product increases, corresponding attention weight increases. Contribution of a value vector to an output vector increases as corresponding attention weight increases. Similarity increases attention, and attention brings higher contribution. Using all input vectors and adjusting their contribution, self-attention is aware of the context described by the set of input vectors. While combining value vectors for one output, value vector of corresponding input moves towards value vectors of other inputs. This is the effect of contextual information. One thing to note is that order of input vectors is not important for self-attention, it is permutation equivariant. If order of input vectors change, order of output vectors change the same way. That's why positional embeddings are added while preparing input embeddings for transformer. Self-attention is the core of transformer. Thanks to self-attention, transformer can process different types of data, text, image, etc., as long as input is represented as a set of vectors. Multi-head attention. Multi-head attention is the parallel application of multiple self-attention blocks. Query, key, and value vectors are computed. Each self-attention block, attention head, works on different projected versions of query, key, and value vectors. Query, key, and value vectors are projected using dense layers with no activation. Dimensions of query, key, and value vectors are reduced. These are the weight matrices, and H is attention head ID. In attention is all unit paper, these are defined as linear transformations and no bias is used. In some implementations, these projections are applied with bias as affine transformations. Attention head works on projected vectors. Sequential linear layers can be represented as a single linear layer. For query vectors, for key vectors, and for value vectors. This is attention head 0. Other attention heads are added in parallel. Outputs are concatenated. And one final transform is applied. Here capital H is the number of attention heads. Default value is 12 for vision transformer. And dimension of value vector is equal to d hidden divided by capital H. Because in transformer architecture, input and output of multi-head attention should have the same shape because of residual connection. That's all for this video. See you next time.